Systems engineering is a tool, methodology, and discipline you need to help deliver your complex or technical project. It was born out of necessity during World War II when Great Britain needed to conduct a study of its air defence systems. A systems approach was used to understand the strengths and weaknesses of the current system in repelling German invaders. Since then, it was the focus of study groups, research institutes, and universities, and has more commonly been found amongst the midst of NASA. NASA used it when designing their space shuttle and other space missions. They adopted it to help try and manage and deliver upon the complex design, build, and test of their spaceship designs. Today, it's more commonly found among government organisations, as well as other industries including maritime, defence, rail, and aerospace. Let's dive more into the detail.
Okay, what is ISO 15288? It is the ISO technical standard of systems and software engineering system lifecycle processes. Basically, it is the governing standard for systems engineering. ISO is a technical body who are the standards authority recognized on a global and international basis, and thus define the technical standard at which systems engineering shall be delivered to. To better understand what systems engineering means to them, let's have a look at their definition. An interdisciplinary approach governing the total technical and managerial effort required to transform a set of stakeholder needs, expectations, and constraints into a solution and to support that solution throughout its life. That's quite a wieldy definition, so I'm going to give you a moment to pause the video and perhaps read through that yourself. So officially, systems engineering and the ISO 15288 standard is a bunch of processes, definition, and concepts. However, unofficially to you and to me, systems engineering is a whole lot more than that. It's about the people, the viewpoints, the understanding your customer needs, cost, time, complexity, risk, and how you communicate all of those factors. This is just some of the core components of systems engineering outside of the very process and definition orientated technical standard. It's much like any other engineering discipline where you know it's a whole lot more than just what you see on the tin. It's about understanding the people and the interaction of people, the systems, etc. So looking at the V cycle. The V cycle is one of the core components of systems engineering. It is one of the technical processes, or actually it is a combination of the 14 technical processes which makes up the core delivery components of delivering an engineering project. This is your bread and butter when it comes down to delivering systems engineering. I won't dive into it too much here because we cover it in a little bit more detail in another section. However, if you want to know what the systems engineering is about in one picture, this is it. The V cycle. Basically, on your left-hand side, you start in the top left corner, work down through each process, but then finally finishing in the top right-hand corner. So, what is a system? A system is defined as a combination of interacting elements organized to achieve one or more stated purposes. That's quite a dry and technical definition of this, but to avoid arguments, it's easier to refer to something as a system instead of its name. This makes sense when you have to decompose the product you're discussing. If you want to discuss a computer, for example, the computer becomes our system of interest. It's now more effective to talk about the system in its elements, such as hardware, software, materials, functions, and form factor. You can put a boundary around the system of interest to enable more effective discussion. This makes sense when it comes to adding things which may make discussion more difficult. For example, if we begin talking about the internet, a computer is connected to the internet, but how do we differentiate between the two? Talking about systems help. What is systems thinking? System thinking is the use of scientific thinking methods to perform a deep analysis on a system. The methods range from scientific principles of reductionism, dynamic modeling, behavioral analysis, and soft systems approaches, which aims to understand the human impact on the engineering of the system, such as attitudes, practices, and procedures. It's typically conducted in stakeholder needs phase of the V cycle as a trade study. It's actually a nice way to develop a real world understanding of what a system does, what the outputs are, and how we can better engineer the system from scratch as opposed to applying a quick fix. Most importantly, system thinking recognizes the human as an interacting element of the system.